Hello everyone, in this video we are gonna be continuing our topic of the assignment further and discussing question number 6 and question number 7. So getting to question number 6, it says define overfitting and underfitting in the context of machine learning model and describe how these issues can be identified and list strategies to prevent them. So what is overfitting? It occurs when a model is very complex and it learns the training data perfectly, including noise and everything very perfectly, and it gives a very good performance on the training set. But when it comes to the test set, it fails miserably. In this condition is known as overfitting. On the other hand, underfitting occurs when a model is like very simple and the data is also like highly biased. So the performance on both the training set and the test set is very poor, like performance very poor on both these situations. And how can we identify them? Overfitting can be identified when there is like a very big gap between accuracy of the training set and the test set, because training set will have its peak performance and test set will have a very low performance. So will be a very large gap, so we can identify it in that way. And strategies to prevent overfitting is by regularization, or you can stop the data early, or you can gather more data so that there are less gaps, or by feature reduction. Now underfitting, how can it be identified? We can identify it by poor accuracy on both training sets. So there is a low on this set, there is a low on this set, it's continuously low. So when this kind of situation happens in both training and test sets, performance is very low, that situation is known as underfitting. Now strategies to prevent underfitting is like make it more complex. Data is like too simple, that's why biasing is happening. So you can add more layers to make data more complex, or you can add features. Features will also will give you better performance, or you can reduce the regularization so there is more variability. So that's the basic difference between overfitting and underfitting and strategies to mitigate them. Now heading to the question number 7. Define logistic regression and linear regression on the basis of hypothesis, parameters, and cost function. How gradient algorithm is used to optimize the parameter. So linear regression and logistic regression. Linear regression is a type of regression. On the other hand, logistic regression is a type of classification. Big difference. The type of hypothesis they use, linear regression uses a linear model, logistic regression uses a sigmoid on linear model. And the parameters, linear regression is best defined by weight defining parameters on a fit line or a plane, and logistic regression is best defined by the decision boundary. Now the cost function of linear regression is MSE, which is mean squared error, and the cost function of logistic regression is log loss, the cross entropy loss. That is it for this video, so thank you for watching.